All right, people, we're going to talk about properties of matter. Okay? Before we talk about properties of matter, we got to know what matter is. So this will be your first note if you're taking notes on this. I will post this. I will post me talking about this online. I'll also post the PowerPoint online. But the best way to take notes is to actually write it in a notebook. So matter, obviously you don't have to write all this. Matter, anything that has mass and takes up space. Okay? So basically everything that you see or touch or feel is matter. If I was going to tell you about some things that weren't matter, light and empty space. That's what I come up with off the top of my space. Light, like radio waves, microwaves, light waves, that's all the same. Electromagnetic waves weren't technically matter because they have zero rest mass. That's a physics thing. And they technically don't take up space. So basically anything else is matter. Okay? Anything you can see, touch, feel, that is what matter is. Matter is a really broad category. All right? Now, a substance. Substance is a really general term. It's anything with a fixed composition. If you're, usually when I talk about this, I would say, if you want to use the word substance, if you're like a police officer and you're taking notes on something you find at a crime, and there's a white powder here, here, and here, then you refer to that as a white substance. You don't know what it is yet, but you know that the white powder in the three different places is the same thing, so you would say a white substance. That's a really general term for matter, okay? Substances can be elements, they can be compounds, like all of these things are substances, okay? But substance is not like a really specific term at all. It's a very general term. So if you know what you're talking about, then you generally don't refer to it as a substance. You can refer to it as an atom or an element or a molecule, and then you're being far, far more specific, even a compound or a solution. But a substance is just super general term. Now, all of these are substances. These are the elements of the periodic table. Okay? Man, this is a old periodic table. Anyway, and it's not quite right on there either. But really, elements is a better word. Elements. Now we're getting more specific. Element is as specific as you can get. When we're talking about an element, we're talking about a substance in which all of the atoms have the same number of protons. For example, if you found a substance and then you determined that substance to be the element carbon, pure carbon, then what you're saying is this substance that I found is carbon because all of the atoms in this substance have 6 protons. Okay? All of them. All of the atoms are carbon atoms. The element carbon, which is the only atom that has 6 protons. Okay? So that's what an element is. An element's being super specific. So substance is very, very general. Element is super specific. Okay? A compound is when you take 2 elements and stick them together electromagnetically. All right? Compounds and molecules are combinations of elements. Water is a molecule. It's hydrogen and oxygen, 2 hydrogens and an oxygen. Sodium chloride is a compound, a formula unit, a compound. Sodium chlorine. These are compounds. Certain combinations of elements, though, instead of calling them compounds, we would call them molecules, like water. And that's something we'll talk about later. So you can have very specific elements, and then you can click them together and make something new. Now, it's important that you understand, and it'll be more important later, but when you make a compound, the compound is very different than the individual elements. For example, and I'll just go over this real quickly, table salt. You need that to live. It's sodium and chlorine. But if you just had sodium by itself and you put sodium in your mouth, it would burn you. If you just had chlorine by itself and you breathed in chlorine gas, it would kill you. But when you have sodium and chlorine stuck together as a compound, now you have something that you have to live, salt. So compounds don't have the same properties as the individual elements that make them up. Okay? It's something new. It's a different substance. Okay, now we're moving quickly. Mixture is definitely a less chemical term. Mixtures aren't compounds. Mixtures are two or more substances that can be separated easily. Okay? The solution, salt water, is a mixture. Okay? If you have some salt water, it's easy to separate the salt from the water. All you have to do is warm the water up, heat the water up, boil it. The water will go away and the salt will stay. That will be physically separating it, okay? But if you have pure water, you can't separate the hydrogen from the oxygen without going through a chemical process or using electricity. So water isn't a mixture. Water is a molecule. But a mixture would be like salt water, okay, where you've mixed salt and water, all right? We're going to do a very big lab, and we're going to film this lab about mixtures. That's going to happen on Monday. So Group B that comes in on Monday is going to have a lab right off the bat, okay? Okay, now when we talk about two types of mixtures, there's heterogeneous and homogeneous, okay? Heterogeneous mixtures, you can see, you can look at them, and you can see there are different things in there, all right? For example, if you had a mineral and it was multicolored, then you could see there are different elements stuck in there. And a homogeneous mixture looks like one thing, like a solution of salt water just looks like water. You can't see the salt in there because it's dissolved. So that's homogeneous. Usually, a good way to think about this term homogeneous is when you think of milk. Milk, when it comes out of a cow, isn't this perfectly white, creamy substance. Okay? But we take it at the milk factory, the dairy plant, and they homogenize it. They bleach it, they mix it, they often, depending on what type of milk they're making, they'll even separate some of the fats out of it. And then they give you this product that looks perfectly pure and white. It's been homogenized. It looks like one thing. Okay? It looks like a solution. Heterogeneous things look different. Now take a look at this. These dudes' shirts are heterogeneous. They're mixtures of different colors of threads. And then you can see that different colors of threads were used in there. Okay? All right. The last thing that we're going to talk about in this little segment of the notes is physical properties. Okay? Physical properties and chemical properties are different. Okay? A physical property is something you can observe without changing the identity of the substances that make it up. That may seem confusing to you right now, but here's what I mean. I can tell you that the shirt is soft. Okay? That's a physical property of the shirt. Now, did I change the shirt by noticing that it was soft? No. Okay? You can just observe it without chemically changing the substance that you're observing. So density is a physical property. If something's a solid, liquid, or gas, that's a physical property. What color it is a physical property. Its buoyancy is a physical property. There are tons of physical properties that you can easily observe. Whether something dissolves in water or not is a physical property. The melting point of something is a physical property. You can take some metal, melt it to find the melting point, and then just let it cool off, and you still have the same metal. And also, liquid metal and solid metal have the same chemical formula. You haven't changed it, you just melted it, right? Okay. And there are intrinsic physical properties and extrinsic physical properties. You don't have to write this down. I'm just going to go over this real quick. An intrinsic property is something within the substance. For example, let's pretend we're talking about a piece of wood, okay, like a 2x4. Or, how about this? If we're talking about this meter stick right here, there are some intrinsic properties. Intrinsic means within the wood. Like the color of this is an intrinsic property. The fact that this probably floats is an intrinsic property, okay? But how long it is an extrinsic property. What do you mean? I could take this thing, break it in half, and now it's not as long. It's still the same color, though, and it still floats. Does that make sense? So you measure extrinsic properties, okay? Mass, volume, thermal energy, which you'll understand later. So the extrinsic property just depends on how much of this you have. But the intrinsic properties are really about the substance itself. Does that make sense? Okay. And here are some other examples of physical properties. Appearance and behavior. Something can be a certain color. It can be magnetic, or it can have a boiling point of 110. Those are all physical properties. How much something weighs is a physical property. The density of an object is a physical property. All of those, you don't have to write them all down, but these are the types of things that are physical properties. Now you may be saying to yourself, well, Mr. Perkins, what's the other type of properties? Chemical properties. Chemical properties of substances are not like this. If I had a piece of paper, some physical properties about a piece of paper like this, and it's white, it's rectangular, it's 8.5 by 11. I think that's the size of a piece of paper. It's flexible, right? Now it's smaller. Now I'll change its extrinsic properties. I could tear it in half. I could make it weigh less. But if I want to check a chemical property of this piece of paper, the chemical property of this piece of paper is that it is flammable. And for me to test that, and for me to prove that to you, I would have to set it on fire. And now I've ruined the paper, right? But I can say, hey, is this bendable? Yep. It's still a piece of paper. So things that you can do and observe it, and it's still paper, those are physical properties. If I set this on fire to see if it was chemically capable of combustion, then I've changed it. So chemical properties require you to change something. And that takes us to the end of this little section, all right?